Okay, as you see, guys, are my title here, the fundamental 4.6 of the fundamental theorem of calculus. And here, okay, that the fundamental theorem of calculus is it has three theorems or three statements. The first one of three parts. The first part, it's here in this page. It states that the area under the curve between any two numbers or constants a, b, such that f is continuous and non-negative, gives here a equals the area from a to b of fx dx.
السلام عليكم.
Alaikum salam. And also we have to know that if x equals a prime of x, and here it's not clear. So I would like to explain this in details in this page. Bismillah ar-Rahman ar-Rahim. So pay attention please with me. Let me first start by this one. Okay. First of all, if we have here a curve, let me draw here a function of some function. This function is, here is the y-axis and here is the x-axis, and here f of x, or we can name it f of here is t, and here f of t. It's a dummy variable because we have more than two variables, so we can write here that it's f of t equals to 2y, and here this axis we will name it later x, but now let me name it t. And if f here is a continuous function on the closed interval, f is continuous function in the closed interval ab, okay, and non-negative, it's increasing. Okay, so in the closed interval a to b, if we let a here and here is what? Here is b. You know now that we can use the definite integral to find the area under the curve and the t-axis of the function f of t between the closed interval a and b using the definite integral. So f of x, we can write it here that f of x, but I'm gonna write it that if capital of or uppercase of x is equal to the integral from, pay attention please, from a to some variable x between a and b, where a and b, where x between a and b, and we can write it a less than or x less than b. So you will find that the integral here from a to x, where is x? X here. This is the first part of the fundamental theorem of calculus. From a to x means that this area here, this green area, is equal to what? Is equal to f of t dt, yes, equals to the f uppercase of x, where x is between a and b here in the closed interval, and this is gonna equal to what? Simply equals to f lowercase of x, and I think that we substituted only x for a function. This is the fundamental theorem of what? Calculus
Mister,
part 1.
the graph is for f of t, right?
Yes.
Not f. Okay.
Yeah, and we have, that's why it's called dummy variable, and that's why we draw here this x between a and b. So x is a changeable variable. That's why we name here this axis as t. Okay, this is the fundamental theorem of calculus. To take the derivative for d over dx of this function f of x, f uppercase of x is equal to d over dx of the function from a to x, from a to x of what? Yes. We move back. Yeah, from a to x of f of t dt, and this all gonna equal to f of x. This is simply what's the fundamental theorem of calculus states, FTC.
مصر يعني f of x is equal to f
This is
prime
part
t.
one. Yeah, for example, I'm gonna give you one example here. The first example. Let me give you here one example for, yes, f of t. Yeah, let's find here d over dx. The question will be like this: d over dx of the integral from 5 to, we start first by x, from 5 to x of this function t squared plus 4 dt. If you like, guys, to know the final answer directly, okay, so simply you will let here x as t, because we said it's in the at the end here it's f of x. Okay, so let me write here x squared plus 4 simply here, and this is the final answer here. But you solve, you let the square root of t squared plus 4 is equal to f of t. Okay, and then d over dx of from 5 to x of this function, and then here f of t, we will replace all the square root of t squared plus 4 as f of, as what? As f of t, because we let it f of t small, lowercase dt. This all is equal to, should equal to f of x. What does it mean by f of x? We have to replace the f of t by f of x, or replace this t by x, so simply your final answer will be the square root of x squared plus 4, and this is finally is your answer, root x squared plus 4. So if you have any question including the t, you can replace directly the x by the t. One more example here. Let me change the color here. Yalla. Here, spin, and yeah. The first or the second example, if we have d over dx of the integral from any letter here, we can, it should be number down here a constant and x is up here. So you know the properties of definite integral, you can change them out. And for here of the square root of x cubed plus 5 d of t squared, sorry, of t squared or t cubed or t, okay, t cubed dt. So the first part of the fundamental theorem of calculus states that the derivative of this integral from x to 4, and one of them is constant, the other limit of the integration is a variable x, you simply can replace the x by t. So when you see this, so your answer will be x cubed plus 5, but you should put negative here. And you know why it's a negative? Because we can write now this as d over dx of negative, and change the positions of the boundaries here. Bring the 4 down here and
Yes,
the
we
x
took it
up, and
last week.
yes, and just put negative before the integration. And here it's x t cubed t cubed plus 5 dt. Okay, why the answer is like this every time, guys? Because we have a proof for the first part of fundamental theorem of calculus, which is, let me tell you why it's here like this, guys. Okay.
So can you go
The
back for a
story,
second? Screenshot.
this one or this one?
لا, after this one.
Yeah. This is another example. Let me name it example 2, and the previous one is example 1. Okay, the story becomes, guys, from here that when we have some function f which is continuous function, we can name it f, y equals f of t, and this is t, and here this is y axis, and this is a continuous function. It should be continuous between two boundaries A and B. So if we have here is A and here is another what? Boundary B. And as we said here, another variable x is between A and B. Listen carefully. What's the fundamental theorem of calculus states? States that f uppercase of x, which is the antiderivative of f of t, okay, is equal to the integration or the definite integral from a to x of f of t lowercase dt. Okay, and this all gonna equal to f of what? F of x, f for lowercase of x. This is the first what? Part of the fundamental theorem of calculus. So to do this, guys, we have to
في
return back.
sound في sound.
What's down?
It's
Echo?
like no, it's like music or stuff.
Music? Where?
Yeah.
اعتقد قرآن هذا.
أو قرآن.
قرآن الشيخ سليمان هنا تكتب. Okay, so to do this, guys, to prove this, we have to return back to first term. And if you know the definition of derivative, which is using the limit. Okay, so let's take the derivative for both sides. Take the derivative. Take the derivative here. F prime of this uppercase of f, okay, the derivative of f uppercase is equal to, do you know, أكيد فاكرينها, the limit as delta x or h approaches 0 of what? Of this function f. Yes, of what? We say x plus h. أنا بدل ال h أكتب delta x, so we have x plus delta x minus f of x, and this over what? Delta x.
When did we take this?
In the first term, the derivative, the definition of derivative, when we have a function and I'd like to find here its derivative by using the definition of derivative. أخذناها بس كانت h approaches 0. You will find, guys, what's the limit here as delta x approaches 0 of, pay attention please, f of delta x plus delta x. Here is a fraction, and let me substitute here, substitute in number 1. Instead of x, I'm going to substitute x plus delta x. So I have the integral from a to x plus delta x of the function f of t dt, minus substituting again by the function itself from a to x. I'll write the same function, f of x all is here in this part, which is f small or f lowercase dt. This all over delta x. It's equal to the limit as delta x approaches 0 of, this is how to prove the first part of the fundamental theorem of calculus. The first part, as you see here, guys, the first part here, this part, yes, this part represents what? This part represents the area, as you know, of the function f of t between a and x plus delta x. Where is it here in the graph? Where is between a and, yes. Let's do it by this blue what color. Where is x plus delta x? يعني delta x is here, يعني زادت على ال x plus delta x. So this position may be x plus delta x. X plus delta x. And when I say the integral from a to x plus delta x of f of t dt, means what, guys? Means the area under this curve from a to x plus delta x. This shaded area now in blue. Okay? This shaded area in what? In blue. Okay, and then minus the integral from a to x f of t dt. Where is it? It's shaded by red. When I say here the integral from a to x of f of t dt, معناها the area under the curve from a till x, and only here. So let me here graphed أو shaded in red. فالماينس بينهم فين؟ الماينس بينهم الماينس ما بين التو areas gives me, yes, let's do it here in pink مثلا or other color, I don't know. Yeah, it gives me here, guys, this part between x and x plus delta x. So simply it gonna be between x and x plus the integral means the area under this curve between x and delta x. This part only, اللي هو the new color pink باين ولا purple. Okay, x to x plus delta x of f of t dt. This all over what? dx. So let me take this rectangle. يا شباب خدوا معايا الريكتانجل اللي هو in purple ده اللي هو between what? Between x and what? And the
X
x
and plus
Delta x
x
plus
plus
x.
delta x. Yes. How to find the area of rectangle? Which is
length.
Length times width.
yes, or the height times what? The base. So what's the base here? The base is the difference between x and x minus x plus delta x. And you have to do it x plus delta x minus x, which
Delta
is delta x. So simply now here delta x. What's the height here? The height, yes. The height here, guys, it's يعني it seems to be a perfect rectangle. موجود معاك perfect rectangle، بس هي مش هتكون perfect rectangle لأن بيكون somewhere of the rectangle above the curve of f of x أو below the curve of f of x. So we have to take what the midpoint rule we have said before. Okay, that we're gonna take a number here c between x and x plus delta x in the middle, such that this c in the middle here has f of c as a height of this rectangle. Okay, because if you take x only, if you take f of x here, this red line as a height gives you what? The rectangle will be above. Okay, the rectangle will be above. If you take x plus x delta x will be below, or vice versa. So if we take the midpoint rule, which is a number between x and x plus delta x, will give us something between the two answers, which is maybe exact answer. Okay, as we learned it before in Riemann's sums. So here my answer will be what? F of c times delta x. Okay, this all area in what? Purple. We can replace it by what, guys, now?
FC.
By f of c times delta x, which is the base times the height. The base times height. So we will write here the limit as delta x approaches 0 of, replace this all in the numerator by f of c, which is the height here of this rectangle, times what? Delta x. And simply cross out delta x with delta x. And the limit as delta x approaches 0 of f of c equals f of c, because it's constant. Okay, because c is a number here between x and x plus delta x. So f of 3 gives what? Gives a 9. So limit as x approaches, delta x approaches 0 of 9 gives a 9. Which is simply equal f of x. Why equal f of x, Mr.? عشان الرول بتقول كده فانا عايز اقفل الكويستشن. No. We have two proofs of an f of c equals f of x. The first one, or the reason يعني ان when I say delta x approaches 0 here, when delta x approaches 0, what happened in this part? When delta x approaches 0, what this blue line happened? يعني الاكس لما الدلتا x approaches 0, x becomes
Approaches
x.
f of t.
approaches x. لا، لما تشيل الدلتا x here تحطها 0 يتبقى لك x. معناه ان الاكس becomes x. يعني this blue line moves to the left and approaches x. وبالمره بياخد السي معاه، يعني بالمره بيزق السي معاه to x. This is one reason. The second reason, you can use the squeeze theorem or sandwich theorem, which is we have studied the first term also. I'm gonna take the limit for all of them. Okay, and deals that as x approaches, as delta x approaches 0, you have c approaches x. And so when f of x, when f of c, when delta x approaches 0 also, تستنتج ان f of c approaches f of x, and this is the first part of fundamental theorem of calculus, that f capital of x represents the entire derivative of f of t, like if here 10, so this one gonna be what? Secant squared, and if here cosine this upper here outside here f capital or f uppercase is what? Negative sign. And simply as we did in the previous questions, لما يجي لك question like this على first part of fundamental theorem of calculus, the derivative of the integral
Sir, can you
from,
go back for a second, please?
yes, 1 minute please. When you have a variable and constant, one of them is below and the other is upper boundary, you have to substitute directly by x. ومالك دخل بالproof only to show you why it's equal to f of x. This is the slide you want, right?
Yes, خلاص I took it.
Okay, طب why we are studying this theorem, guys? Fundamental theorem of calculus. Yes, between integration بتعمل connection between integration and differentiation. يعني connect between the integral calculus and the differential calculus. This is one reason على why we studying the fundamental theorem of calculus. Number two, any continuous function f on the closed interval ab has an antiderivative f uppercase of x. اثبتت يعني للناس ايام نيوتن ولايبنز، اوكي لايبنز، ان هو any function f of t has its antiderivative f uppercase of what? of t، بشرط ان ال f of t هذه تكون continuous and non-negative over the closed interval a and b. okay guys.
نيجاتيف ولا
so عملت حاجتين. نعم. number one
لا
connect between
لازم
integral
تكون
and differential.
لازم تكون نيجاتيف ولا
non-negative.
اوكي
non-negative. okay, so let's take examples of this part, guys, how the questions come to us, and the special cases. Let's start by the first example. Example 1, when you have d over dx of the integral from here, it should be a number, should be a constant. Be a constant. From x to 4, we took it yes, from 0 to x, from 0 to x of the square root of t squared plus 4 dt. Who can solve it now? As a student, guys, in grade 12, you should write only that the answer equal to انت عارف دلوقتي ان هذا كلها f of what? t. So this all gonna equal to what? f capital or f uppercase of t or f of x, because f of x, the upper one, the uppercase one, is equal to at the end, it's the antiderivative of f of x. So simply I will replace this t by x, so I have x squared plus 4. Okay, so how to pick your answer quickly? You just replace this t by x. Okay, in example number 2, the problem when you have not x, you have x squared or x or cosine x or tan x, or you have two functions up and down, not constant, and variable x. Let me take here example 2, d over dx of the integral from 5 to x squared. Here's another example, 5 to x squared of f of t dt. Okay, it's given like this, and you have مثلا او not given like this. بديك الفانكشن بديك مثلا radical. Let's take the upper one, radical t cubed minus 4 مثلا t cubed minus 4. How to solve this question? d over dx of the antiderivative of 5 to
replace x by we replace t by t cubed by x squared ونحط x to the power of 5.
Yes, we will replace it simply. We will replace it by x squared, and the new thing here, guys, and pay attention all of you, please, that you have to multiply by the 2x, like the chain rule, multiply by 2x. Okay, this is in a simple way. Why? It has another proof also, but no need to take it here. مش محتاجين نعرف البروف بتاعها، بس لما يكون فوق variable is not x, it's a function x squared, x cosine, tan, any other function, not x. Okay, you have to replace the t by x squared and this all to the power of 3 minus 4 عادي, And then don't forget to multiply by the derivative of x squared. And all of us know it's 2x. So my final answer is 2x into radical x to the power of 6 minus 4. This is your final answer. Okay, and then this all from what to what? Huh?
What, mister?
Yes. Leave it like this, اللي هو 2x وخلاص. Okay, radical x 6 minus 4. So again, what's the second case when we have number 2? The second special case when we have x squared or another function not x, we have to multiply by its derivative before you after you substitute x14. طيب. One more example number 3. Example number 3, find d over dx. I think we have cosine and sine here. Where is it? Yes.
And what if the
Yes.
x squared كانت تحت
حلو.
بدل
لا
5؟
لا شوف دي خلينا ناخده in the next slide عشان نحتاج مساحة. Example 3. What's the d over dx of the antiderivative from x squared to x cubed of a function? X squared to x cubed of a function, because all these examples outside the book, so I wrote them here in my copybook. So it's t to the power of 4 minus 2 dt. Yeah, شباب. Yes. We have now, this is name it the third case, or third special case, when we have x squared down and x cubed up here. So what's the answer? The answer simply, step number 1, we will let, pay attention please, we will let f of t is equal to the function inside the integral. Okay, then replace it here and replace this all by f of t. So we have, here is the answer. So we have d over dx of the antiderivative from x squared to x cubed of f of t عشان اروح للfirst part of fundamental theorem of calculus. What this all equal, guys, is equal to f capital of what? We have d over dt, d over dx, sorry, of this all here is f, as the fundamental theorem of calculus states, is equal to f capital or f uppercase of x, f uppercase of what? Of t now, وبعدين تعمل substitution from what? From x squared to x to the power of 3. Okay, equal. Substitute first by x cubed in the function gives the square root of x to the power of 3 all to the power of 4 minus 2. Okay, and then minus, بس ما ننساش نعمل multiply by what? By the derivative of x cubed, which is 3x squared. And then minus, substitute by x squared in a function, which is the square root of t, the square root of x squared.
ليش حطينا 3x squared؟
The derivative of x cubed. Okay. Here again, let me write it here. X squared على كم؟ Power كم؟ Power 4 minus 2 and multiply by 2x, which is the derivative also of x squared. ده باختصاري. So write your final answer as 3x squared. Okay, radical. And the x power 3 by x power 4 x 12 minus 2 and then 2x and then radical x to the power of 8 minus 2. So this is your final answer. يبقى دي third case لما يكون فوق وتحت في عندك variables. Okay, and each one of them غير x. You have 3 cases. أول واحدة اللي هو لما يكون 0 to x. ده عادي برضه الاكس instead of 18. لما يكون بس x squared، لما يكون cosine، لما يكون tan، لما يكون x cubed، x anything, we have to what? Multiply by its derivative. بعد ما تعمل substitution كان الاكس مكان التي، okay, so multiply by the derivative. Substitute x cubed بدل التي and then multiply by 3x squared. And here the same. Replace dt by x squared and multiply it by 2x, here the derivative of x squared. Okay. Okay, here, when we move back to the first slide, fundamental theorem of calculus, as you see here, the area under the curve between a and b, closed interval a and b, is equal to the definite integral from a to b, f of x dx. Yes. Okay, f a prime, يعني the antiderivative of a is f of x. Okay, يعني here the derivative of a is f of x. And your answer of this function equals a. And if the f of x is 2x, if it's x squared, sorry, so a is 2x. If here f of x is 10, so a is 6 squared, and so on. So a prime of x is f of x. And a of a equals 0 لأن من a لل a ما تحرك من مكانه هنا واقف عند ال a. And a of b equals طبعا a كلها because you moved from a to b يعني أخذت كل المساحة وكل الاريا. Okay. The formula a prime of x equals f of x states that a of x is an antiderivative of f of x, which implies that every other antiderivative of f of x on the closed interval can be obtained by adding a constant c. يعني if capital أو if uppercase of x equals ax plus c by any antiderivative of x, and consider that happens when we subtract f of a from f of b. And this is, guys, the second part of the fundamental theorem of calculus. This is the second part. هو بدأ في الكتاب بالsecond part اللي هي f of b minus f of a is equal to the antiderivative أو definite integral from a to b of f of x dx. I'm proving هنا ان f of b minus f of a يعني لما نعمل substitute بال b in the f uppercase minus f of a equals, when we subtract them together, ax plus c minus x plus c, the c gonna cancel together and we still have a of b minus a of a of a, he let it equal 0, and a of b is equal to a, which is equal to a. Okay? And now, finally, you have to know that this is the second part of the fundamental theorem of calculus. I mean, the definite integral from a to b, اللي هي the area يعني under the curve from a to b, equal f of b minus f of a, which is the same steps we are using when we found the definite integral, like your homework, guys. When the question is asking you, مثلا, to find what's the derivative of 4 to 5 of any function x squared dx, what's your answer? You are using بالفعل هذا الايه الرول اللي هو what's the integration of x squared, it's x cubed over 3, and then you are substituting 5 first, which is f of b minus f of a, and I'm gonna find here x3 over 3 when it's 5. Now let us do it directly. We are substituting بالفعل هنا شباب 5 for x. Okay, minus 4 for x again to the power of 3, and then find your final answer. Because here f uppercase represents the antiderivative of this function f. So f small or f lowercase of x هي ال x squared, and f uppercase which is x cubed over 3 here. Okay. وطبعا ال b اللي هي ال upper limit وال 4 the lower limit of this integration. And he proved here for you why f of b minus f of a is the same as the area of this function. I would like to stop here, and then we will take in details in the second part of the fundamental theorem of calculus. This is the second part. This is part 1 in the book. Okay, I started by the first part, and here is the second part. المفروض بالفعل the second part in other books. So we will inshallah study it tomorrow. Thank you يا شباب, and see you inshallah.
Thank you, Mr.
السلام عليكم.
وعليكم السلام.